This is the RVschwarzenegger solar battery charger. It uses a 12-volt solar panel to safely charge a 52-volt lithium ion battery. It also has an adapter to allow it to be used with a 12-volt cigarette plug. And it also has an adapter to connect directly to a 12-volt battery in a car. It uses maximum power point tracking to get the maximum power out of a solar panel. It's got a knob which allows the user to select between 8 different modes. It's got 3 modes for a solar panel, allowing you to charge your battery to 80%, 90%, or 100%. It's got 2 modes for the cigarette plug, allowing the user to either draw 1 amp or 5 amps. This prevents from blowing one of the car's internal fuses. It also has 3 modes for the direct 12-volt battery connection, allowing the user to either push 0.5 amps, 1 amp, or 2 amps directly into the 52-volt battery. Here it is set up in my carport, charging my e-bike with a solar panel. It uses a custom algorithm to study the solar panel's properties in order to pull maximum power. The green status light flashes whenever the charger is pushing current. It will stay steady green whenever the charge is complete. Here you can see that we're pushing 41 watts into the battery from the solar panel. It can also be used directly with the 12-volt source of a car. Here it is plugged into my truck's cigarette plug with an 8 amp internal fuse inside the car. In order to not blow the fuse, I have my charger set to 5 amps. You can see here that it's pushing about 25 watts into the battery from the cigarette plug. The charger outputs diagnostics over CAN. I've set up the solar panel outside with the charger inside so that I can go over the diagnostics. I pulled 100 feet of wire from the solar panel to the charger. This is going to lose a lot of efficiency. I use a CAN dongle in order to interface between the system and then a laptop. These are the messages sent over CAN. You can see there's the software version as well as the hardware version. This is used after a firmware update to know that the update succeeded. It also tells you if the system is running a release version or a debug version. The release version runs much faster and has better performance. It outputs the rotary switch state, so I know the setting that the user has chosen. This is the output properties of the system. You can see that the battery is about 51.5 volts. Output current is used to know how fast the battery is charging. The input message allows the user to know the efficiency and properties of the solar panel. I also output the heatsink temperature so that you can know if the system is getting too hot. I also send out a lot of the battery properties. This allows you to know the state and status of the battery, as well as how much power has been driven into it from the charger. I round the battery voltage and put it through a filter so that I know exactly when to stop charging. I also continuously add the power to know the total kilowatt hours added to the battery from the charger. Here, panel properties can be studied in order to better optimize the maximum power point tracking. The charge session properties allow the user to see how stable that the charger is. Now you have a way to charge an e-bike with a solar panel, allowing for an even greener mode of transportation.